And you know there's only two sports here, basketball and baseball. Everybody else, that's why so many football wasn't a trend until the last 10 years. Is you would, as a football player, you get a larger size. The only portion of your contract is guaranteed. And they have to pay it to you up front. So some of these guys sign a $100 million contract with an $80 million signing.
All right, we're gonna get started here. Looks like we have a pretty empty class today. I don't know if that's because of the crazy traffic or people just decided not to show up. Guess we'll find out if people start rolling in. But anyway, we are going to change topics a little bit. We briefly talked about ORMs on the last class, and I had mentioned to my class that what we were doing there was kind of an ORM. It was really just taking the SQL functionality and putting it in an object so it was easier to call queries over and over again and make slight changes and kind of have some flexibility, right? So you didn't have to write the same select statement or the same insert or update or whatever over and over again. What a real ORM does is not only that, makes it easier to call general queries, but it also it takes your data from your database, takes it out of that row format and puts it into a nice object for you to be able to use, right? So you can imagine if you have a user and the user has a bunch of login attempts, you could potentially get a user object out with an array of login attempts from the ORM, as opposed to getting a bunch of users and then getting a bunch of login attempts in two different data sets and having to match them up yourself. The ORM can kind of do some magical stuff for you. So they're pretty nice. We're going to start talking about one called Sequelize today, but first we are going to refresh ourselves with MVC architecture. So, a couple quick overviews if people don't remember. How does MVC work? Well, you've got a user. They're going to be playing with your website. When they make a request, it's going to come to the controller. That's the C in MVC. That controller is going to delegate to the model or call to the database directly, however you view your model, and it's eventually going to get a model back, and the model is going to represent data in the database, right? Once the controller has the model, the controller will also know what view is related to that request response chain, that model, all of that fun stuff. It'll find the appropriate view, it'll put the model and the view together, or at least put the data from the model into the view, and then return the view to the user. So we go all the way around this chain here. The user makes a request. They get the data from the database. They end up with a model. The controller then finds the view and hooks the two up with the data and then sends it back to the user, right? And MVC is a pretty common architecture. You're going to see, I would say, more newer apps don't really follow traditional MVC. Granted, if you use Angular, Angular is considered MVC, and it is, but React is not at all. And you won't see MVC-like architecture at all with React. So, you know, it's a good thing to know about. Will you be using MVC often? Probably not. It's more of an organizational pattern than anything. It's an architectural pattern, right? But it's a little long in the tooth these days. So it's good to know about. And when you get into it at work, you might run into some applications that use it. So anyway, what would it look like in our Node application? Well, we would start with our server.js, and there's a whole bunch of stuff going on here. So we'd have like our HTML routes and our API routes, and potentially even our ORM connection. This could all be controller. It could be split. These could be the controller. This could be the model. These could be the controller, and the model could just be the data coming from the database. It's really kind of up to your design, right? And then over here, we have the different views. So your HTML effectively and handlebars. Our handlebars files are our views because they're just HTML and they can take in some data and dynamically render it, right? That's all they do. Nothing too crazy. So anyway, that's kind of the gist of MVC. If anyone has any questions, again, on what it is or the particulars, feel free to ask. Otherwise, we'll just keep on chugging. Nope. Okay. We'll close this up. All right. So let me start this app. We are going to be starting with a little example app that's going to refresh us on all the things we've done so far. So it's going to be called Chirpy. It's our crappy Twitter version. You can submit, and then it'll show your chirp and the time you chirped and the day of the week and all that fun stuff. So what this is going to let us do is, again, play with handlebars. We're going to play with a MySQL database. We're going to create some queries to that MySQL database. We're going to have Express, all that fun stuff. Just again, this is our warm-up activity to get back into the groove before we start looking at SQLize and how we can replace our MySQL layer with SQLize, make things a little bit more convenient for us. So you can go ahead and partner up on it. I don't care. This is activity number 1. And go ahead and work on this for like the next 20 minutes or so, and we'll go over it.
Yes. Oh,
squeezed in like an extra.
Just kidding. No, I think it's underrated.
I didn't even have my phone either, so I couldn't ask. I feel like an episode of Naked and
Okay, let's go ahead and go over our Chirpy app. So this is our review of MySQL, and there's no handlebars in this one. It's just a traditional HTML page with some JavaScript that we use to load up our chirps. So first things first, don't forget to npm install. If you use the MySQL Workbench, then you load up the schema SQL into there so you can create your database first. If you do it from the command line, you can do it from the command line. But don't forget to use that schema to go ahead and create your database in your table. It's pretty important, or else your queries won't work. Okay, so first thing we got to fill out our connection. So this connection I think will work for me, but you have to go in here, fill out. We want to use localhost right now. We're not going to connect to any remote servers at this time. We will do that later with our homework, right? Because we'll have to deploy MySQL and stuff like that to Heroku. But for today, we're not going to do that. Your user password, your database, which is Chirpy, and all that fun stuff. Once you get that running, you'll be able to run the server.js file, node server.js, and you should get a connected message as usual. You should all recognize this by now. So any questions on the connection stuff? Everyone is good with that, I'm assuming at this point, right? We've been going through it for a while, so cool. So our routes, let's look at our API routes. We had to add 2 routes, an API to get all the chirps and an API to add a chirp. So the get all chirps is just gonna basically run a select star on our chirps table, and then we're gonna return that result as JSON. Now again, why are we doing this? Because we're just using JavaScript jQuery to make AJAX calls to our server and get the data back. This kind of model it's interesting that they chose this instead of using handlebars. This is kind of what a React app looks like, right? All of your routes have just get, put, post, and they return JSON and stuff. And then you have JavaScript that effectively does AJAX requests to get those endpoints, to get the JSON data. You don't have these templates or anything like that with React. It's all hosted as a JavaScript file. And actually with React and Angular and all those, you really just have one HTML file that has effectively nothing in it, and then you hook into that with your JavaScript. So it's pretty nice. So this kind of a layout for an API is something you should get more familiar with, just using JSON on your API and nothing else, right? So anyway, that's the get all, just a select star from our chirps table. And then we have a post because we need to add new data, and post is used to create data, put is used to update, post is used to create. So because of that, we don't need any parameters in our URL or anything. We're just creating new data with what we pass in. So we're going to have just a blanket insert statement. We're going to insert an author, a body, and a created at. And here are 3 parameters right here that represent, respectively, the author, body, and created at. So we'll run our connection query. We'll pass in the SQL query, DB query there. Boop. And then we'll pass in the author, the body, and the created at, respectively. And if we have an error, we're not going to handle it in this example. We'll just, kind of blow up. Otherwise, just call res end, and we're good to go. Any questions on these routes, how they work? This is pretty much a review at this point, right? So is there anyone who's still got questions about any of this stuff? It's okay if you do, because we've obviously covered a lot in the last few weeks. So let's go ahead and look at our index.html. Like I said, this is just your traditional index.html. There's not a whole lot going on. There's no weird handlebars templating or anything. You just had to add some elements to be able to display your chirps, right? So you could call it the chirp area, whatever you wanted to call it. You just need something that you can reference with jQuery and JavaScript to be able to load in your chirps. So if we look at the JavaScript, chirp.js, this is basically our client-side stuff. Right when the page loads, you can immediately run a jQuery get to that API all endpoint, and you're going to get some data back. That's going to be all of our chirps, right? It's going to be in an array format. Okay, don't ever do this. There's no reason to do this. 0 is falsy, so just do that. You guys all familiar with falsiness, truthiness of JavaScript elements at this point? So when you're doing a length check, you don't need to check if it's 0. You just check if it's true. If it's true, it's not 0, you know you have stuff in the array. Or even better, if you really wanted to be cool, you could do if not length return, right? So what this is going to say, if you don't have anything in your array, we're not going to do anything. We're done. Then you can do the for loop. What this does is it removes a level of nesting in this code because we're no longer writing all of our logic inside this if statement, which makes it easier to read and easier to refactor later. So that's just a refactoring tip for you. Anyway, that's how I would write this code. Let's start using const and let as well. I know Daniel told you guys on Tuesday and Thursday about let. I also told my class about const. Const means that the variable's not going to change after you create it. Remember, objects generally don't change. Changing means you would have const object equals new object or something. If you just have const object and then you change the properties of the object, it's okay. It can still be a const because you're not actually changing the underlying object. You're changing the values of the object. So, for instance, we can make this jQuery row a const because we're calling functions on it, but we're not actually reassigning it to something else. We'll go into that in more detail as the class goes on. We have like a week where we talk about ES6 syntax, but if you have questions, let me know. Anyway, we'll change that to our let and our const. We're going to go ahead and loop through this chirp array. We're going to create a new div with jQuery. We're going to give it a class, chirp class, and then we're going to create the data based off the author, the body, the time it was created at using moment. And then we're just going to prepend it in that chirp area. So that's just the first time through. We go ahead and load everything. So right here, this is going to be our chirp form where we're going to do our submit. We need to do our prevent default. We create our new chirp with the data from jQuery, and we pull it out of those elements, right? Reference them by their IDs. That's what our little octothorpe here means. We can console log our chirp just so we can make sure it's formatted properly before we post it. And then we go ahead and post the new chirp. In this case, we're using .then instead of the callback. .then is the promise, right? So promise is another way that you can handle those callback systems. Granted, if there's a function with a callback like this, it doesn't mean you can automatically use .then. It just means that sometimes, in the case of jQuery, for instance, the function offers a .then version of it as opposed to the traditional callback. So you got to really look at the API docs to make sure that that's actually the case. All right, so again, we post our new chirp, and then we can go ahead and add that new chirp. Now notice we're not actually getting the new chirp back from the database. We're just using the new chirp we created, because if .then happens, we know that the post was successful. It completed, that chirp's been added to the database, so the data we already have can be added to the UI. We just go ahead and add it, prepend the row, just like with that get. Right? And then we can go ahead and clear out the old values. Any questions on any of this code? Nope. Cool. All right, let's move on. So I said before we started this review exercise that we were going to talk a bit about Sequelize today and learn what that is. So right here is the docs. These are the docs for Sequelize. They're pretty thorough. I was going through them a little bit last night. They're okay, I'll be honest with you. There are some things I had to hunt for, but I think they're overall pretty thorough once you know how to navigate through them. So get used to looking up docs like this, because you're going to have to do it. If you read down to the bottom, you can see, oh, getting started guide. They have that. They also have the API reference, so it tells you everything you need to install. It tells you the supporting packages you need to install, how to set up a connection, test it, how to build a model query, and all that stuff. So this little getting started guide kind of gets you off your feet, on your feet, whatever, and going. So like I said, most of class today is going to be going over this Sequelize library and what we can do with it, and we're actually going to be doing that Chirpy app again, and we're going to be replacing the SQL queries in that Chirpy app with Sequelize. So that's going to be like our first activity, right? So we know how it works without Sequelize. We know how to create the database, create the tables, create new chirps, select new chirps, and then we're going to go through and reformat that with the Sequelize stuff, okay, and make it a little bit more convenient for us. So what does this ORM add? Well, it adds a lot of convenience. There's a lot of things it handles for you. For instance, creating database tables is real easy. You just call .sync or something along those lines, right? And it'll create the table for you. Stuff like that is just done for you, which is really, really nice. So what we're going to do is I'm going to Slack out this link. And what I want you to do is you're going to go through these docs with partners or whoever, and I'm going to Slack out some questions for you, and you're going to try to answer all of those questions based off these Sequelize docs. Kind of get a feel for, oh, Will already got me on that, get a feel for what Sequelize is and how it works and what you need to do to use it and those kinds of things. So let me go ahead and Slack out the questions. Alright, I just Slacked out the questions. Like I said, take about 15 minutes, work with a partner or two, and go through these docs and try to answer all of these questions. We'll go over them when you guys are done, and then we'll get started working with Sequelize.
What point is there too many toppings on the pizza? I'm just adding too much you know, to me, I don't know, it just seems like there's so much going into it now that seems to kind of convolute the process.
In regards
Well,
to
like, say for example, the SQLite, is it really helping that much to users, or I can't really wrap my head around it because there's just so much now.
when you are so to answer the question about an ORM specifically, when you're working on an application that has 50,000 queries, yeah, it helps a lot. Yeah, so there's a fair amount of abstraction away from the actual process, and there's different ways to think about it. I think in the beginning what you should try to accomplish is learning some of the foundational aspects of the language you want to use and then being as productive as possible. And that's what these tools are really good for. Now, as you get further in your career, taking a step back and learning how they work and stuff like that is really valuable. But in terms of all the crap that's kind of on top of what's actually going on, if you at least understand how to use that stuff, you can get your foot in the door, and then you can spend time retrofitting the information later. So
essentially we're just getting super exposed to, you know, an inch of water a mile wide
yeah,
versus
it's the whole glacier thing, right? You see just a little bit of it, and then there's so much underneath the surface. So yeah, I don't disagree with this approach of teaching you so many different things, because yeah, sure, we could spend 24 weeks on the foundations of JavaScript probably, and you'd be an expert on JavaScript, but then you wouldn't understand any of the libraries or anything. Could you figure them out? Sure, but teaching you the ecosystem first is a good start. I agree with that. And then you can kind of retrofit the other foundational information later, because that stuff's not super important to get your job done, to be completely honest. What's important is that you can use these tools effectively and quickly. And so teaching you that, priority. All right, let's go ahead and talk about this. So, SQLize is, it's a lot. It's probably, I would imagine, seeing it for the first time, still being relatively new to this whole ecosystem, it's pretty intimidating, right? Because there's a lot going on. I don't know if anyone feels that way, but I would imagine it would be that way. I know when I first jumped in to programming, things like this were intimidating, and I kind of shied away from them because I was like, well, you got to learn this whole new library, and oh gosh, it's a ton of work. And the reality is, it does save you time. Heather actually just asked a really good question. She said, imagine we have a pizza and we keep throwing toppings on top of it. At what point do you have too many toppings? There's really no pizza anymore, right? We're learning all these things about the JavaScript ecosystem, and we're just kind of piling them on, and we're kind of stepping further and further away from the language itself, right? And just learning about the foundational concepts of the language and programming and how those things all work. And that's true. We're kind of like abstracting away the how it works part and just giving you productivity tools, but that's really, really important. The way I explained it to her was basically, yeah, so you can go back and retrofit the information about how this stuff works later, but what's really important for us to teach you is what the ecosystem is, how it works as a whole, what kind of tools you can use, and how to be productive and efficient as quickly as possible, because that's really what does your work, right? Being productive and efficient, not knowing how JavaScript computes something, right? Sometimes that's helpful if you get in a real sticky wicket, but it's pretty rare that that happens, especially in web development. So understanding the ecosystem, understanding the tools that exist, and understanding how they work is far more important in the beginning than understanding the foundational concepts of what's going on. Now, filling in that information as you get further in your career is really valuable. It can prove to be quite powerful for you to progress, but in the beginning, it's not so important. So I do agree with how much information we're kind of vomiting on you at once. I do think that just has to be done, and it sucks because it's overwhelming, and it feels like you're kind of drowning in new information, but the reality is this is what has come of the JavaScript ecosystem, and we have to accept it. So, it is a lot, and actually it's calmed down as of late, but, for a while there's like a 2-3 year period where it was kind of a running joke. Like tomorrow, there's going to be a whole new JavaScript ecosystem we're going to have to learn, because it was in flux for so fast, and in flux, so much flux, that it was just insane. You had to keep up with like 50 different things at once. It's not as bad now, but it still kind of has that same vibe, right? There's just so much. So anyway, I imagine SQLize is pretty intimidating. So going through the docs, was it helpful to kind of like go through the docs first and try to answer structured questions about this before we even look at it? Do you guys think that that was valuable? Now you kind of know where we're going with Sequelize and a little bit of what it does. You're not an expert by any means. You haven't seen it in action, so we can't really, you know, guarantee that what you're reading here makes sense, but at least we have an idea of what this thing can do. With that in mind, what is Sequelize? Who can answer that? An ORM, exactly. It's exactly what it is. What advantages does an ORM offer? What was that? Someone say something? Shortcuts? It offers a lot of shortcuts, yeah. So what are some of those shortcuts? Well, one, it makes querying easier. It makes validation easier. It makes creating and deleting stuff easier, right? It does a lot of stuff for it. The setup is easier, right? So it offers a lot of shortcuts for things that we have to do manually that are really quite tedious. And the thing is with SQL queries, like, there comes a point where you're like, okay, I know how this works, right? And so you're just writing the same thing over and over and over. So the faster you can get that setup and initialization done, the more effective it's going to be. Yeah, there'll be quirks to the library you're using. Sure, there always will be. This stuff's really complicated, but frankly, that setup stuff just sucks. So who wants to do it? How do I install it, and how would I incorporate it into my app? So first off, how do I install it? npm install Sequelize. How would I incorporate it into my app? You'd require it. Yeah, require it. You could create a connection, do all that kind of stuff. What is a Sequelize model, and what role does it play? Another word for table? Yeah, that's effectively what it is. It is an abstraction around a table in your database, right? So it represents a table structure. It represents how you're going to add stuff to a table, how you're going to change a table, how you're going to get records from a table, stuff like that. So I use the word abstraction a lot. Does everyone kind of understand what I mean when I say that? What was that? Well, the term abstraction itself is more like... oh, extraction. Okay, yeah. So, is anyone familiar with what I mean when I'm saying abstraction? Basically, like there's some concrete model, right? Like our table in MySQL. We all know what a table is now. We know what it looks like. An abstraction is something that sits on top of that and takes away the details, right? We don't care about the table. We don't care that it's in MySQL anymore. We just care that there's a user and there's something persisting information about that user, right? That's what Sequelize does. It abstracts away the details of MySQL, the table, the queries, and all that stuff, and leaves us with this nice interface we can use, the Sequelize library. So when I say abstraction, I'm talking about something that takes the details and hides them from us, so we no longer care. Because the reality is we shouldn't care about those details in a lot of these things. Okay, yeah, so the model is a table effectively, and it plays the role of our data manipulation. Okay, so let's say we have a table. Let me pull up these questions. Really quick, so we can look at this together. All right. Let's say we have the table below in MySQL. Country, which has country names, phone code, which has some digits there, the capital, which has the capital name, and the independence year, which has some year. How would I model it in Sequelize? It's kind of a big question, right? It's kind of hard to just say. So how would we model this? Well, we would create a model, right? So there's the Sequelize create function. Let's go ahead and pull up the docs on the model. So if we go to the getting started, or Sequelize define, I'm sorry, and we look at this your first model section, we'd have this Sequelize define, and we could define a name for this table. Let's just call it countries or something, right? And then from there, we have an object that represents the fields, their types, constraints about them, information like that, related to that model. So remember, we have a country name, we have a phone code, we have a capital name, and we have an independence year. So the country name would be what type? A sequelized string. Probably, yeah, because it's going to be like a varchar, an nvarchar in our MySQL database. The phone code would be what? An sequelized integer, right? Because it's just going to be probably an int in our database, or even a small int or something. And then we had capital name. What is that going to be? A sequelized string. And then we had independence year. That'll be another integer, right? So we would have a model that looks like this with 4 properties: country, sequelized string, phone code, sequelized integer, capital, sequelized string, and independence year, sequelized integer. And that's how we would define this model, and how we would effectively create that table. Let me pull it up again. We create that table in our MySQL. Now, to actually create the table, we'd have to call one more thing. We have the model. Let's just say we have a var table model. What function can we call in that table model to actually create the table? Do you have your hand up, or are you? Yeah, what is it? Sync. Yeah, there's a sync function you can call on the table that actually, or on the model that actually creates the table. And you can actually pass in an object that says force true, force property set to true, and that destroys the table and recreates it if it already existed in the database. So if you have migration changes or something, you could do that. How would I query the table for all records where the independence year was less than 50 years ago? So what's the function we use to query stuff off a model? Find all, right? There's a find all function we can call. And the find all function, let's go to the model API reference. Find all. You can see right here, it's here. I can click it, boom. Brings me here. Find all has some sub options you can use in this little object. For instance, if we want to do a where, well, we need to find the independence year. Was it less than 50 years ago? Yeah, where the independence year was less than 50 years ago. Okay? So we would have this where clause where independence year, and then we'd have a less than. I think we have a less than, and then I don't know if it's just the independence year minus 50. Let's look at their solution. So we could get today's date minus 50. Oh, greater than today's date minus 50, right? So what this allows us to do is basically say, take today's date, we'll get the year. Let's just minus 50 from that full year. And then everything with a year greater than that is going to be a country that has found independence in the last 50 years, effectively. Right? Does that make sense? I know this is a lot that we're kind of throwing at you, and we'll play with it in a moment, but new date, just like that, is today, right now, this exact second on your computer. .get full year obviously gets the year. No, that's just a JavaScript date. So JavaScript has a built-in date object. If you do new date, you get this date object represents right now. You could also do date.now, but then you get the milliseconds based off of the epoch time. So that one's a little less useful unless you know what you're doing with it.
Doesn't greater than make that greater than 50 years?
No, so it's taking today's date, or today's year, 2018 minus 50, so 68, right? And it's saying every country with an independence year greater than 1968. So that is in the last 50 years.
Okay.
All right, how would I query the table? Order it by descending independence years and limit the results to show just 2 of the records, skipping the first 2. This one's a lot, so I wanted to just show you the answer. So if you go back to the model specification, or the model API, not that chirpy. Go back to the model API, you can see right down here we have this big long list of params. And this is really where you figure out what you can do. So for instance, we want to order by. Okay, well we have options.order. We can read, it takes in a function, a column, a literal, an array. The easiest one's probably the array. And you can see the example here is we have order by an array with an array in it. The first array, the second array, the inner array, is going to have two elements always: the name of the column and whether it's descending or ascending. So DESC for descending, ASC for ascending. And then if you wanted another column after this inner array, you'd put a comma and then another array with the column name and ascending or descending. Right? So this tells us how we can do the order. Now, is this the easiest doc to read? This actually is a pretty good one, all intents and purposes. I know it doesn't feel like it because there's just a lot of information, but they're telling you everything you can do, which is a far cry from what other API docs do sometimes. Limit. So it doesn't tell you much about what it's doing. There's no description, but that just represents the limit call in MySQL, right? So in this case, we want to limit it to 2, so we would set limit to 2. Offset. Well, we're supposed to skip the first 2. Offset allows you to skip however many records you put in there. So we would put in 2 to skip the first 2 records because it's actually going to bring everything back first and then sort it. So the offset will happen after it's brought back all the records, right? So we'll say skip these 2, just like let's cut them from the table, and then we'll sort it. So how do we use those? If you scroll down here, you can actually see an information of, well, that's find all and count. You can see again up here the find all where you have a where. Instead of where, you'd put offset or limit or whatever, and that's how we can get to this answer. Offset 2, we're skipping the first 2 records. Limit 2, we're only bringing back 2, so there's only 4 records in this table, I think. Oh, 5. Okay, great. So we're just skipping 1 altogether. So 2 of them are being truncated off. 2 of them are being skipped. 1 of them is being skipped, and then the last 2 left, or the first 2, based off of this independence here, are going to be the 2 we get. And then again, we order by. Do we need to reference it like this, SQLize column, or can we just do independence here? I'm sure both work, but you'll find out when you get in there. Now, I will say, I am not an expert at SQLize. I have never used it in a production app. I've only used it in this course, really. So there might be things we run into where I don't totally know the answer, so I'm just warning you ahead of time. I'll have to do some research and answer you either at a later time or during the activity or something. How do I use SQLize to make changes to an existing table with data in it? Well, the SQLize command line that we'll see at the end of class has migration tools. You could also change the model specification in code and then just do a sync force, which, you know, is kind of dangerous because it blows away all your data. So I don't always recommend that, but you could do it. It's okay to do that when you're developing an app, right, before it goes to production, because until it goes to production, none of the data stored in that database is important. Any questions on any of these? Any questions on SQLize? I know, again, this is a lot that we've kind of jumped into. We're about to see an activity with it, so we'll get a little bit more hands-on and start to figure out how it actually works. But if you have any questions now about these or just kind of general SQLize, feel free to ask. Nope. Okay. We are going to take our Chirpy app, and we're going to see what it looks like now with SQLize. So if you have the GitLab stuff loaded up, or downloaded to your machine, the latest changes, you can open activity number 3. So there are a couple of things to note with SQLize. One, yeah, you need the SQLize package for sure, but we also need the companion library that represents the database we're trying to talk to. In our case, we're trying to talk to MySQL. So far, we've been using the MySQL library from in Node, but SQLize actually requires MySQL 2. Yeah, it's good naming. MySQL 2 is, I was looking at the docs for yesterday, apparently faster, better than the MySQL one. Don't know why we weren't just using that to begin with, unless the differences have kind of been mitigated and maybe MySQL is almost as good now. I'm wondering if this one supports the 8.0 authentication. I haven't tried yet, because that'd be great. If it does, I'm going to be pretty upset that we wasted like 6 hours combined class time when we could have just used this library. But that's an aside. So when you install SQLize, you also need the companion library that works with the database we're talking to. In this case, SQLize will tell you you need MySQL 2 if you're trying to use the MySQL dialect in that connection. Okay? So, as always, we do our npm install. Make sure everything's good to go. Let's check out this Chirpy app. So if we look at the server.js, Nothing crazy here. This all looks pretty much the same. And the reason why is our connection stuff, our SQLite stuff, is used in the controllers in those routers and stuff, right? They're not used here in the server, so nothing here should be too surprising. It's all pretty much the same. So why don't we start with our connection, right? So we already saw, we've seen some of these SQLized connections maybe in the docs if you saw them, in that getting started doc if you look through that. So the connection is slightly different. Because it's an ORM and it works with several different types of database, it can't be exactly the same as what we're used to with MySQL, right? It has to have a similar interface because, frankly, all the databases really pretty much use the same type of connection string. It's very similar. It's not always exactly the same, but they're very similar. So we have the database that we're connecting to inside of our server. Then we have our username is the second parameter, and then we have our password. Those are like the default parameters, but after that you can specify your options, and we're going to need to do this always because we need to specify that we're talking to MySQL. Now, could SQLite figure out that we're using MySQL? Maybe, but I'm not sure how. Maybe it just, I don't know. You need to give it the port to talk to at the very least. In that case, it probably could figure out it's MySQL. Maybe, but I'm not really sure. So we have to specify our host, always localhost for us right now. Our port should just be 3306, the default MySQL port. The dialect is going to be MySQL. That's a string. This pool here is not super important. You don't actually need it, but it is recommended. These are good defaults. So what the pool is, when you create a connection to a database, there's something called a connection pool, which basically creating a connection to a database is very, very expensive and computationally. So they create a connection pool which basically keeps connections alive, concurrent connections alive, if you're using them often, so that you don't have to recreate them. You can just grab one from the pool and be like, I'm just going to use this one because it's currently not being used. What this says, I don't know exactly, but my guess is there can be at max 5 concurrent connections. Minimum 0, so that means you can have a pool with no active connections in the case that you're not using them. And idle 10,000 is probably it's probably going to be 10 seconds, or I would guess this is in milliseconds, so it's probably going to be every 10 seconds. If you haven't used a connection, it'll die. So if you have a really high throughput server, right, that needs to create these connections very, very often, they're going to stay alive. But if you haven't used one in over 10 seconds, there's no point to keep it around because they're expensive, not only to create, but to keep, right? They take resources, so we should get rid of them. Idle is the only one where I'm not totally sure if that's exactly what they mean, if they mean something else. We can look at the docs later if we really want to know. But that's what this pool means. You don't need it. If you don't have it and you expect high throughput, you're going to have a problem, but we don't expect high throughput right now. We're just learning how these tools work. Anyway, once we've created the connection, we can go ahead and just export that SQLized connection because we're going to use it in our models. Any questions on the connection part of this? How this works? Cool. Okay, so there is a schema SQL, but this is mainly just to create the database. Even though we're going to be creating the tables and stuff with SQLized, we do still need the database on our server. There might be a way that you can use SQLized to connect to like the MySQL database and then create the database with just a one-off query. I'm sure you can do that, but we're not going to do that here. So if you're following along, I would run this in your MySQL workbench. I'll just go ahead and run that.
Is there something different that goes on with the backticks?
Like, around the name?
Yeah.
Yeah, so MySQL allows you to put backticks around a name, especially, it's really only necessary if you have spaces in the name. So basically it allows you to create spaces in your database name if you want to, which is not recommended at all. But if you ever see like select columns or whatever with the backticks around them and tables with the backticks around them, that is the most pedantic way to write a query because it allows for spaces and special characters in the names and stuff, which my personal opinion is if you need to use backticks, you did something bad. So don't do that because it just adds another layer that people are often going to forget. So unless you enforce totally pedantic queries, which who wants to type the backticks for everything? I don't. I never do in MySQL. Unless you have totally pedantic query requirements in your workplace, try to avoid spaces and stuff in your names. Also, let's be real in programming. We should all know at this point, spaces in any name are a bad thing. If you have spaces in any of your folder names, please get rid of them for the love of God, because that is only going to cause you pain and suffering. Replace it with underscores. So, I created the database. We're ready to go. That's good. Let's go ahead and look at the model. So, again, we need to import SQLize. Require SQLize because we're going to need to use it for the data types. We can require our connection. They, didn't name this very well. They could have called this connection or something to make it a little bit easier to understand, right? Even though it's SQLize, it's fine. We can still call it the connection because it's the SQLize connection, right? But naming is hard. So we want to create our chirp table. As opposed to creating the database schema ourselves by hand and running it in MySQL Workbench, we can go ahead and define this model, chirp, and give it our same columns, right? Now, what I don't know, what we'll find out when we run this, is I don't know if it'll create like an auto increment ID for you, or if you have to specify that. You should always try to be as explicit as possible. So if this does create an auto ID increment, which I'm gonna assume it does, that's great, that's awesome, but it's not explicit, and someone who hasn't used the library is not gonna know that. So you should, when you're defining your tables, you should always explicitly define those. It's only better for everyone else. In programming, you should be as explicit as you can before you start causing grief, right? If it causes a lot more work to be explicit, then think about it. This isn't a black and white rule. But for a little thing like this, where implementing ID type SQLize integer auto increment true primary key true, was that a lot of extra work? I don't think it was, but it's super explicit. We know exactly what the primary key is. We know exactly that it's going to auto increment. We know it's an integer, right? And so I just saved you a lot of grief. You don't have to guess anymore. We know that it's going to work. So I'm going to take this out anyway because I want to see what SQLize is going to do. But you should not do that in your code. I'm going to tell you right now, in my shop, that's a bad practice to not have that. That's my shop, though. Maybe I'm just a dick. I don't know. But anyway, we've created our model. Now we need to sync it with the database to make sure the table's created. Now remember, sync will only work the first time when there is no database table. If you want to overwrite the table, you can go ahead. Holy God. You can go ahead and do force true like this, and it'll drop the table and recreate it with your new columns or whatever if you want. This is really, really dangerous in production. Don't do this in production because you're blowing away all the customers' data, right? And that's probably not a good idea. You can imagine if Twitter was using this and they all of a sudden did that and blew away a whole bunch of tweets, people would probably be pretty upset. Any questions on this model and how it works? Alright, so this UI stuff hasn't changed at all. We're not going to look at that. The API routes, let's just look how these have changed because now they're querying from SQLize and no longer from the MySQL connection, right? So you can see here, instead of just requiring that MySQL connection, we now require the model we care about. And in this case, we care about the chirp model. So in our get all chirps or whatever, we literally call chirp model find all with an empty object, which means just bring back everything. This is a select star from table. It's as simple as it gets, right? And then just return the results. That's it. That's much cleaner, much easier than writing select star and all that stuff over and over again, right? Or select where or whatever. Now to create a new chirp in our post, we take our request body, we call chirp.create, and we pass in the required properties. Now in this case, I would not pass in an ID, right? ID is an auto increment integer, so it's going to create it for me. If you were doing an insert in the database yourself, you would not insert the ID, would you? So we're not going to do that in my SQLize either. If you do include it, I'm not sure if SQLize will error out or ignore it. I don't know. I've not used SQLize enough. But it'll do one of the two. It'll either say don't include that property because you literally can't change it, or it'll just ignore it and not give a shit what you put in there. So we're going to give the author body and create it at from this request. If you know that the request is properly formatted, which we're making that assumption, you can cheat a little bit. I'm going to show you this. This is cool syntax we'll get to later. But you can do, if I can get here. That is the same thing. That's functionally equivalent. This is an object spread. Takes all the properties out of an object, puts them into the new object, basically. But you have to guarantee that your properties are named the same, right? Created at is literally created underscore at. Body is literally body, and author is author. No capitalization changes or anything, right? They have to be literally the same for this to work. So it's not safe unless you can make that guarantee. And I'll be honest with you, taking a request body and doing that is usually not very safe, because all of your clients that are using that request are required then to properly adhere to that interface. You won't have any normalization or anything in front of it, which you should probably have. But this is just an example, so what can you do? Anyway, we create it, and then we just call .then, and if it succeeds, we'll get some results back, and we're good to go. If it fails, we won't get to the .then. Any questions on these queries and how they work? All right, let's see this bad boy in action. Oh, jeez. Oop, I did not shut something down. Kill that one. Okay, so you can see here when I run it the first time, there's actually this message right down at the bottom that shows create table if not exist chirps, and actually shows the SQL query that it ran on that chirps table, which is kind of nice. You can see it did create an ID integer not null auto increment for me, and then it assigns the primary key to ID. So it does do that implicitly. But like I said, I think explicit is a little bit better, because you never know. SQLize could change that. I doubt they will. They'd probably have a lot of uproar, but they could change that or something. Or what if you don't want it to be an ID? You know, you need to override those things. What if you want to call it something else, right? So anyway, you can see the SQL query it runs, which is kind of nice. If you ever want to know how to make like a complicated column type or something, you could build it in SQLize if it's easier, and then just see what it outputs. So that's pretty cool, I think. So let's go ahead and open it. So we're here again. My new SQLize chirp. And it is functionally equivalent. This is the test version of Carson chirps. So from our UI, it looks exactly the same, but behind the scenes, it's a little easier. Now, it's hard to see how much benefit it adds for the small one. There's 2 SQL queries. Really, there wasn't a whole lot going on. But you could probably imagine if you had 50,000 queries or even 20 queries, it makes a big difference. It makes things a lot easier, especially because you can add validation and all kinds of stuff to just save you a lot of grief. And then here, it actually even logs out what's happening, so that's cool too. If you watch your log, you can see what's going on with SQLize, and if you have like some sort of a logging system attached to this process, once you have it deployed, you could even pull up the logs later and like go through and see what was happening. You know, it's pretty neat. It's a neat tool. So, any questions on SQLize in the API and how that works? Okay then, activity number 4, we're going to take a Star Wars app that we built previously with MySQL and handlebars and all that, and we are going to change it to use SQLize. Yeah, Adam.
It didn't save on database. It shows on the application when I type, but it
Uh-huh.
doesn't save anything in the database. Like the database and table it was created,
Uh-huh.
still is empty.
Did you...
Refresh.
Yeah. Mine did it. At least it has one of the records. Interesting. Yeah, I'm not sure why it's only showing 1 because, I mean, I could go refresh this page and 2 should still be there. Yeah, so they're in the database, and if you refresh the page and they're still there, they're there. Something's up with MySQL Workbench, probably. Even better, if I restart the process, they should still be there. So, mine are stored in the database for sure, even though my MySQL Workbench didn't show them. And you can see. Alright, so activity number 4. Work on that one. The Star Wars activity, you're going to be replacing it with Sequelize. Feel free to use this activity we just did together as kind of, you know, like a helper. Help you get through those tedious things like building the connection and all that. You can just copy them. Not really that important. So, work with partners too, because this one's going to be pretty tough. But we'll work on this. We'll go over real quick, and then we'll probably break for lunch.
Usually that's there. Doesn't say it all. Yeah, something. I think that was direction. Yeah, we can start. Yeah, that's pretty cool. No. Yeah, no, it's great.
Yeah. It's significantly shorter, like, I'm nervous.
Or review the data. Yeah, I can see the database and Kirby or whatever. Dude, I got like multiple you're setting in the first hour of the class. Dude, it automatically looks at me.
All right. Let's go over the Star Wars app refactor. So there were some instructions on things you needed to change in the Star Wars app to make it sequelize. You're going to use sequelized models, sequelized collections. You're going to use the sequelized querying. And so it was a big undertaking. So what the original app gave us was a MySQL connection. It gave us this kind of ORM like we made last week, right? And then in our API routes, we use that ORM to get our data, serve it to our HTML and all that fun stuff. So the first place to start, in my opinion, is with the connection, right? So the connection's the easiest place to change it. Obviously, your whole app after that is busted, so there's no real way in this kind of a refactor to change things incrementally. I mean, you could keep the old connection and build the new connection and then replace one query at a time if you'd like. That's one way to do it, but this is a pretty small surface area, so it's okay. Anyway, we create our SQLized connection. We have the database we're connecting to, which make sure you have that created before you do this. We have our login information. We're connected to MySQL, connecting to localhost port 3306. Default pool information if you want it. You don't need it for this little example, but we always have it in there. Any questions on the connection? How the connection works? Cool. So the next thing would be to create the model. So if we look at the original schema, we actually have what effectively is our model, right? So we can build our SQLized model off of this table here. So it has an auto increment ID, a route name, a role, an age, and their force points, right? And we can see the data types associated with those as well. So we require SQLized. We bring in that connection we just built, and we start defining this model. Right here, you'll notice that this table name is different than this. So if the table already exists, or if you don't want it to pluralize the table or something like that, you can tell it to freeze the table name. What SQLized is going to do by default is pluralize this word. So if you character, it'll make it characters, user to users. If you do freeze table name, it won't. So this should just come out as character. Unless, yeah, it'll probably just come out as character. If you have freeze table name, if you don't, it'll be characters, right? So what values again do we have? We have an ID, a route name, a name, role, age, force points. You don't technically need to define that ID, but if we were going to define that ID, we could. So remember, you need to do the object here instead of just the type, which you should probably get in the habit of doing anyway. This is going to be a SQLized integer, not instance. It is going to be auto increment true. It is going to be primary key true. Then we've defined our ID. Route name is a varchar, which means it's going to be SQLized string. Name is varchar, SQLized string. Role is varchar, SQLized string. Age is going to be an integer, SQLized integer. Force points, also an integer, SQLized integer. And then any other options you want. Like I said, you don't need these, but you can. Now, to create the table, we just call the sync function, and voila, our table has been created. And then we can export our model. Any questions on this model, how it works, how we do anything here? Yeah. Yeah. Okay, sure. Yeah, so do you need me to start from the connection or just this file?
More precisely the table.
Okay. Okay. So we have SQLized define tells us we're going to be creating a new table, right? Well, we're going to be defining a model, and that model maps to a table in the underlying database. We're going to call it character. The model's going to be defined as character. It'll automatically be generated as characters in the database. You could call it characters right here if you wanted to. It's really kind of up to you. So from there, we have our table is going to be created. That's just an empty table. Now we have to define the types of the different columns. So if we look over here, we have our create table statement. We can use this as the original schema to map up to our SQLized table. So ignore this for now. Sequelize will implicitly create the ID auto increment for you, so you can keep it that way if you'd like. If it's a lot of extra work and it's hard to remember how to do this, it's fine for now. Don't worry about it. When you get to a production level database or you're working in a full dev shop, I would think a little differently, but for these it's okay. So since the auto increment primary key is taken care of for us, we can just ignore it. So we need to define all of these as properties on our model, right? So let's start with the route name. If we look at route name here, we have route name. It is a varchar 255, which means it's effectively a string in MySQL. It's not null. By default, these values are going to be not null in Sequelize, so we don't need to define that. We just need to find the data type. There's no varchar in Sequelize. We just call it a string. So since route name is a varchar 255, we're just going to make it a Sequelize string. Cool? With me on this? Same for the name and the role. They're both varchars in this table over here. And they're not null. Nothing special. They're effectively going to be Sequelize strings. So we give the name property, the role property, we make them both Sequelize strings, and boom, those columns have been defined. Now age and force points, they're also not null. They're integers. Don't worry about the 11. That's just the display type. So since they're integers, we know we can define them as integers in Sequelize. No special options because they're not nullable and all that. So now we have all our columns defined. If you like, you can pass in secondary options to the model. In this case, we have one called freeze table name, which just basically tells Sequelize when you're defining the table name in the database, use this literally. Don't pluralize it, do whatever Sequelize does. So you don't need this, totally optional. Now we have our model, we can call sync. Sync creates the table in the database. It'll actually run the create table if exists or if does not exist, whatever. And then we export the model for use. We good? Question?
That would be only once everything is working.
What, the sync?
Yeah.
The sync, what do you mean?
Well, we'd have to have like our connection with SQL.
Yes, you need your connection with MySQL and through Sequelize, so that's got to be done. So that's imported up here, right? That has to be first, because we're using that connection to define the model, right? So yeah, once your connection's established, then you can sync. If you don't have a connection, it's not going to do anything. It'll fail. And the sync only happens one time, right? If the table already exists, it's not going to create it again. So now our model's defined. Let's go to our API routes. This is the last bit we have to change. Instead of requiring in our old ORM, I'm actually going to... Jesus, what just happened? Instead of requiring in our ORM, so here's the old version. Here's the new version. We have our ORM in the old version. This is the one you guys started with. We have an API route to get character, get a specific character, right? And we call this search characters function, which is going to return an array of characters or a single character based off of whatever one it finds. If you don't pass in a specific character, it'll just return all of the characters. On this side, we bring in our ORM, our Sequelize model. We have the same URL specification. So this question mark at the end basically says that this variable is not required, and it can still do a match on the route without this. So this one should technically have it too, but I think, oops, not that. This one should have it too. Make sure it works properly. So if we have a character defined, we want to find that one character. So we'll do a character find one here with our Sequelize model. We'll define the where. And the route name is the one we're using to actually find the character. Because remember, route name is the special normalized name of that character without spaces or anything weird, so it can actually be used as a route. Otherwise, we have no character to find. We're just going to get them all. So to create a new one, in the old version, we just had an add character function. If we look at the ORM class and look at add character, you can see that there's quite a bit going on. It uses a regex to get rid of the spaces for that route name. It does an insert into. There's a whole lot happening here, right? Our sequelized version, similar, but it's a little bit more compact, right? So we still create the route name where we get rid of all the spaces and we make it lowercase. But then we just call character create, pass in the properties, and call it good. Now we should probably wait for the .then here. Before we call res end, because the way it was doing it was kind of assuming it would always succeed, and it probably will. But so for this app, it's not a huge deal, but in the real world, problems can occur. And there you have it. We have the sequelized version, yeah.
Can you kind of go through line 40? I don't understand the spacing to replace one.
So it takes the character name from the request, right? So you'll pass in a name in the JSON object. This is a replace function, which it looks for a string and replaces it with a string. So what you could also define this as like that. It says look for a space, replace it with nothing. It wouldn't quite work though, because this one finds all of them. So this is called a regex. Your regex always starts and ends with forward slashes like this. \s represents a space. Plus means one or more. So it's looking for one or more space inside of the string. So right here, if your name is Carson Howard, it is going to find this one or more space, right? And it's replacing it with this character, which is blank, so it's effectively going to do this. And then we call toLower on it, right? The reason why we need to use this regex is because we have this G at the end. G means global, means find all matches, not just the first one. By default, it'll find the first one. So if my name was Carson Howard the third, which it's not, and I did not have this G, or for instance, I just had that, it would only do this, which isn't what we want. Now with the regex, it'll give me this, and then we call toLowercase, and that's how our route name is calculated. That's what that is doing. Regexes are very complicated. When you have a regex, it solves a problem but causes another one, and then the next problem is you have a regex.
Is there a better solution then?
No. In this case, it's pretty much the best solution, because this is a very simple regex. The reason why they're infuriating is because sometimes they're 50 characters long and you have no idea what the hell it's doing. People abuse regexes because they are so powerful. But for this, there's not a better solution. This is as good as it gets. The alternative is to loop through it and find every space and replace them all manually, which works fine. So that's a regex. If you want to learn more about regexes, Google it, because we don't go over much in this class. They're pretty complicated. There's a lot to them. Any other questions on this?
Yeah, tell me again the question mark after characters. What is
The question mark in the API route says that it does not need this parameter to match the route. It basically says that this and this are functionally equivalent. And if there's a character, it'll use it. Otherwise, it doesn't care. That's what the question mark means. It's optional. Any other questions? Cool. We will Slack out the solution, go to lunch, be back at 12:45. Stopping the stream until 12:45.